Hello, everyone. My name is Dr. Martin Zhu, and I am a co-founder of i2Cool Limited. Today, I'm going to share the technology of our company. So welcome, everyone, for attending the seminar of today. Let's get started. Our company actually is incubated by CTU Hong Kong Tech 300 program to commercialize the technology developed in our laboratory. So why do we need to study the cooling? This is our world. We need to spend a large amount of energy for air cooling each year, resulting in a large amount of carbon emission as well. So if there's a technology to reduce the energy consumption of AC systems, it would be great for both our environment and society. In the Sahara Desert, there is an ant that can survive in an extremely hot environment. This is because the special structure on the skin that can keep its surface cool. And inspired by this structure, we develop a coating that can highly reflect most of the sunlight and emit 8 to 30 micron of the energy to the cold universe simultaneously. And our atmosphere is transparent to this wavelength. That's why the energy dissipated from the coating can just go into the universe and be absorbed by the cold space. And in the experiment, we can find that as compared with the normal white coating, our product can achieve 4 to 7 degrees C temperature reduction. And based on the energy conservation principle, we can calculate that our product can save at least 120 kilowatt hour per meter square per year on the building by reducing the surface temperature, reducing 70 kilogram carbon emission. And because of the low cost of our product, the payback period of the customer is less than 1 year. It means that after 1 year, the client can just keep saving the money by reducing the electricity cost of the air conditioning systems. And the lifespan of our materials can last for more than 5 to 10 years. That's why our product can save our clients money in operation costs in terms of the electricity for air conditioning systems. And we have also gotten a patent in mainland China and Hong Kong. And also we got the certificate from some third-party laboratories, such as these two key parameters, which are solar reflectivity and mid-infrared emissivity. As you can see that these two numbers are all, both of them are higher than 95%, very close to 100%. For the normal white coating or normal cooling paint in the market, these two numbers are normally in the range of 80 to 85%. That's why we can achieve sub-ambient cooling, while others cannot. And we also passed the safety requirements in the European Union. So our materials can actually be used in most of the countries in the earth. And incubated and supported by CTU, we have launched the market. We have launched the product to the market in November last year. And after that, we have collaborated with many local developers, organizations, and government departments and some companies to demonstrate the cooling performance of our materials in Hong Kong's local climate. And we have also collaborated with some outdoor facility owners to show that our cooling materials are actually can be applied to all the surface in outdoor environment for cooling, not only the building application. For example, this a logistic company that need to store their foods using a refrigeration supply chain. Using our materials can also reduce the petroleum cost of their supply chain. And we can also combine our material with solar panels to cool it and enhance the electricity generation. And also we can combine the technology with some other outdoor facilities, such as cheat water pipe for some centralized air conditioning systems in high-rise buildings. And this is one of our draft cases. As you can see in this project, we have coated 50 meters square on top of the surface. And below the surface, we have two rooms which are identical, one with coated and another one without coating for comparison. So in this project, as you can see, in July, the surface temperature can be reduced by 30 degrees C by using our product. And there was 150 millimeter thick thermal insulation between the surface and indoor environment. As you can see that the indoor air temperature can be reduced by 5 to 6 degrees C, even with a thick thermal insulation. And based on the estimation that if we turn the AC up for like 1 degree C can save 7% electricity, our technology can save around 40% of the energy consumption for air cooling. And this estimation can verify in real applications. And in this project, we collaborated with a local developer in Hong Kong and test our materials in a shopping mall. I mean, on the roof of a shopping mall. They have 2 rooms, one for control and another one for testing. As you can see, from June to July, because of higher ambient temperature, the fan and air conditioner in the AC systems are increased by 35% and 62% in terms of energy consumption. But in the room coated with our product, these 2 numbers, one for the fan, just increased by around 8%, and the air conditioner systems are decreased by around 6%. So overall, our technology can save the energy consumption for the air conditioning systems for 42.27%. Based on the real data feedback from our client. And overall, per meter square, our materials can save 430 kilowatt-hour per year. So in this case, the client will just need to take like 2 to 3 months to pay back. And in the future, we will launch more color options for the cooling paint. And we have also investigated different colors, such as blue, green, pink, purple, and yellow. As you can see, the solar reflectivity will be lower, a little bit lower, but still higher than 90%, even higher than the reflectivity of normal white paint. So this second generation can maintain the cooling and display the colors simultaneously. So actually, apart from the building applications and some other outdoor applications I have mentioned, our materials can be applied to all the surface in outdoor environment for cooling purpose. And we will also turn this technology to textile, like a fabric. So in the future, we can launch cooling mask, cooling hats, cooling umbrellas, cooling clothes, and even the cooling curtains for high-rise buildings to be installed on each floor of the building. In the past 1 year, and supported by the Hong Kong Tech 300 of CTU, we have demonstrated and introduced our technology to various sectors of the society and got significantly recognized by different people. So in the future, we hope to collaborate with more building owners, more owners of outdoor facilities to extend the applications of this electricity-free cooling technology to aid carbon neutrality. Thank you.